All right, buckle up, because today we are seriously deep diving, and I mean really deep diving, into the
Yeah.
mind-bending world
Yeah.
of black holes, dark matter, all that
Uh-huh.
crazy cool stuff.
All the kazoo.
And to guide us on this journey,
Mm.
we've got two guys who probably, like, eat cosmic mysteries for breakfast.
Remade.
Neil deGrasse Tyson and Brian Greene.
And the best part is we're not just, making stuff up here.
Right.
We're actually tapping into a conversation between Tyson and Greene, these brilliant minds,
Oh, we love it.
like grappling with the universe's biggest puzzles.
Yeah, it's like eavesdropping on, like,
Yeah.
Einstein and Hawking just, like, hashing it out over a cup of coffee or something.
A mind-blowing coffee.
And get this, it all starts with what seems like a simple question from, a listener.
Okay.
What happens when a quark, one of those tiny particles,
Yeah.
falls into a black hole?
And this is where it gets really interesting
Yeah.
because, as they point out, nobody really knows.
Really?
Not even Brian Greene. And this is Brian Greene we're talking about.
You're kidding?
Like, seriously.
I kind of find it comforting
Yeah.
that even Neil deGrasse Tyson can ask a question
Right.
that just stumps, like, the smartest people on the planet.
Exactly.
Like, you think with all our fancy telescopes and equations and everything, we'd
Yeah.
have black holes figured out by now.
You'd think so.
But nope, still a giant cosmic question mark.
Still a mystery.
Right.
But what we do know about quarks is fascinating in itself.
Yeah.
Like, Tyson describes them as being like, those creepy identical twins that are always connected?
Okay.
You try to pull them apart, and the force pulling them back together just gets stronger.
Yeah. Oh,
okay.
It's really bizarre.
So they're, like, tied together with some sort of, like, cosmic rubber band.
Yeah, like an invisible rubber band.
What happens if you keep pulling? Do they just, like, snap back together, or?
Well, it's even weirder than that.
Okay.
At a certain point, the energy you're using to pull them apart,
Yeah.
it becomes so intense
Yeah.
that it actually creates two new quarks.
What?
So instead of pulling them apart, you end up with more quarks.
Hold on. So you're saying they, like, multiply?
It's like they multiply,
Yeah,
exactly.
that's insane. So if a bunch of quarks fall into a black hole, wouldn't that just create this, like, insane chain reaction?
It's a quark party,
Right.
and it just keeps getting bigger and bigger.
Oh, my gosh.
And Tyson actually uses this great phrase. He calls it a quark catastrophe.
Which I think is the perfect way to describe it,
Yeah.
This sort of mind-boggling chaos.
Right. Well, what
Our
happens?
brains just, like, melt trying to even comprehend it.
Our current understanding of physics just completely breaks down at the singularity of a black hole.
It's like we need a whole new set of rules
They need a whole new rule book.
to even begin to, like, wrap our heads around it.
Absolutely.
That's both terrifying and amazing at the same time.
It's the ultimate mystery.
Right. All right, let's move on from the
Yeah, from the crushing,
crushing gravity of black holes to something a bit lighter.
little lighter.
How about a cosmic celebrity?
Are you talking about the Higgs boson?
Maybe.
The rock star particle?
Yeah.
The Beyonce of the universe?
Yes. Okay, so the Higgs boson.
Help me wrap my head around this whole Higgs field thing.
Okay,
It's what gives particles mass.
that's right. Imagine a cosmic party, right?
Okay.
The Higgs field is like the atmosphere, the vibe.
Yep.
Some particles, like our friend the Higgs boson, are super popular. Everybody wants to interact with them.
They're like the life of the party.
Exactly. This makes it hard for them to move through the crowd.
Right.
They've got mass.
Okay, so they're like,
They're bogged down.
they're trying to get through like a mosh pit at a concert.
Exactly. Now, other particles, they're like the wallflowers, barely noticed.
Oh, no.
They zip right through the crowd, almost like they have no mass at all.
So they're like nobody even,
Nobody even notices
they're
them.
just like blending into the background.
Exactly. They're the unknown artist. No one's asking for their autograph.
I love that analogy.
Oh, it's a good one.
So the Higgs boson gives other particles their mass by basically making them popular at the cosmic party.
That's the gist.
That is so much more fun than reading about it in, like, a textbook.
Way more fun.
But speaking of mass, there's this other mysterious stuff lurking out there.
Oh, yeah.
Dark matter.
Yarr.
This is where things get really interesting.
And this is where Tyson, he doesn't hold back in this conversation.
Okay.
He actually calls the quest for a single particle explanation for dark matter, quote, intellectually lazy,
Oh, wow.
which, coming from him, is a pretty bold statement.
That's putting it mildly.
Right.
So is he saying that we're, like, oversimplifying things?
He's suggesting we might be missing something fundamental.
Okay.
Like there might be a different explanation entirely.
Yeah.
Something we haven't even considered yet because our current models are too limited.
Interesting.
Now, this isn't to say there aren't any interesting theories out there.
Okay.
Take supersymmetry, for instance.
Okay. Supersymmetry. That's the one where every particle has like a hidden twin, right?
Exactly.
It's like a whole other set of cosmic Legos
Right.
that are just out there that we haven't found yet.
Exactly. And the crazy thing is,
Yeah.
this theory, it actually predicts a particle
Yeah.
that fits the description of dark matter perfectly.
Really?
It would be stable. It wouldn't interact with light.
Oh, wow.
It'd be like the perfect cosmic ninja, you know?
Hiding in plain sight.
Exactly.
Oh, man. So we've got like a suspect,
Yeah.
but no evidence.
Yeah. We have the theory.
It's like my kind of mystery. But seriously, though, if these supersymmetric particles are really out there,
Yeah.
why haven't we found them yet?
Well, that's the million-dollar question, right?
Are you?
I mean, we've been searching for decades
Yeah.
using these incredibly powerful particle accelerators, like the Large Hadron Collider.
Right, right.
And so far, nothing. So it's possible
Yeah.
that these particles are just really, really good at hiding.
Okay.
Or
Yeah.
maybe, just maybe,
Yeah.
there's something else out there, something we haven't even begun to imagine.
Okay, my mind is officially blown.
Right.
We've got black holes defying the laws of physics.
As they do.
We've got dark matter playing hide and seek.
Exactly.
And now we're talking about like a whole other universe of
Mhm.
undiscovered particles.
It's a lot.
What could possibly top that?
How about the possibility that the universe is held together
What?
by wormholes?
Wait, wormholes? Like those like shortcuts through space-time?
Yep, those ones.
Like from sci-fi movies? I
Yeah.
thought those were just theoretical.
I mean, they are theoretical,
Yeah.
but here's where it gets even more wild.
Okay.
Greene, he proposes that the emptiness of space,
Yeah.
it isn't actually empty at all.
Okay.
It's actually teeming with these virtual particles
Okay.
that are constantly popping in and out of existence.
Yeah.
And these particles, he suggests,
Yeah.
might be connected. Guessed it, wormholes.
Hold on.
Yeah.
So you're saying these like tiny little fleeting particles
Yeah,
are creating like tunnels through space-time.
potentially.
How is that even possible?
That's where quantum entanglement comes in.
Okay.
It's this really weird phenomenon where two entangled particles,
Yeah.
even when they're separated by like huge distances,
Right.
can influence each other instantaneously.
Instantly.
It's like they're connected by some invisible thread,
So it's like faster than the speed of light.
faster than the speed of light.
Wow. That doesn't seem fair.
It's true.
Okay, that's a little freaky, not going to lie.
Yeah.
But how do we go from like entangled particles to actual wormholes?
So imagine those
Yeah.
invisible threads between entangled particles as like tiny wormholes.
Okay.
So instead of picturing like the smooth fabric of space-time,
Right.
Greene's envisioning a universe that's like woven together by these microscopic tunnels.
So it's like the universe is just one giant interconnected web.
Yeah.
But if these wormholes are everywhere, then why haven't we seen any evidence of them?
Right.
Like, why can't I just hop in a spaceship and take a shortcut to another galaxy?
Well, because these proposed wormholes would be incredibly small.
Okay.
Like on the quantum level,
Okay.
we're talking like we'd need a microscope
Yeah.
the size of a galaxy
Oh,
to even see them.
not practical.
Not really, no.
Right.
And even if we could find them,
Yeah.
the physics of actually traveling through them, that gets even more complicated.
Egg years. Leave it to the universe to dangle this, like, cosmic carrot
Right.
and then be like, nope, you can't have it.
Exactly.
But speaking of mind-blowing concepts,
Okay.
Greene also touched on something else.
Yeah.
That's got physicists scratching their heads.
Which
Extra dimension.
yes.
So we experience the universe
Right.
in 4 dimensions, right?
That we know of.
3 spatial and 1 time.
Right.
But string theory, this is like one of the most
Yeah, it's like the leading theory.
it's like the leading contender for a theory of everything.
Exactly.
It suggests there should be many more dimensions,
Many more. Yeah.
like 10.
Possibly 10. Yeah.
Okay, my brain might actually break if you try to make me visualize 10 dimensions.
I don't blame you.
So if these extra dimensions are real, where are they?
That's the question, isn't it?
Right. Where are they hiding?
Okay, so think of it like this.
Yep.
Imagine a garden hose.
Okay, got it.
stretched out really long
Yeah.
from a distance.
Yeah.
It looks like a one-dimensional line, right?
Right.
But if you get up close,
Yeah.
you see it's actually got this two-dimensional surface.
Okay, yeah.
So these extra dimensions,
Yeah.
they might be kind of curled up in a similar way,
Okay.
just incredibly tiny,
Okay.
billions of times smaller than an atom.
So we're like those ants crawling on a piece of paper,
Exactly.
completely unaware of the third dimension that it's like embedded in.
Precisely.
But here's a real question.
Yeah.
If these extra dimensions are so small,
Yeah.
how can we even hope to detect them?
Well, it all comes back to gravity.
Okay.
You see, gravity, it's influenced by the number of dimensions it can act in.
Okay.
So if these extra dimensions exist, their gravity might be leaking into our four-dimensional world.
Interesting.
We just need to figure out where to look.
This is what I love about these deep dives.
I know, right?
We start with one mystery,
Yeah.
and it just unravels into this whole network of, like, cosmic enigma. It's a rabbit hole
Right.
of cosmic proportions,
But hold on, we can't forget about, like, the elephant in the room.
which is,
Dark energy.
oh,
This
yeah,
mysterious force that's, like, pushing the universe apart.
right. And it's getting faster.
Yeah, faster and faster, and nobody knows why.
It's one of the biggest mysteries in physics right now.
Okay, so what's really fascinating about this, though, right, is that quantum physics,
Yeah.
which is, like, arguably the most successful theory that we have for explaining the universe at, like, its most fundamental level.
It's a pretty good track record.
It falls apart when we try to apply it to dark energy.
Yeah, it doesn't quite work.
Wait, so you're telling me
That the equations that work perfectly for everything else
pretty much?
just go haywire when we start talking about dark energy.
Essentially, yes.
That's concerning.
Yeah, a little bit.
How much are we talking here? Like, how far off are these predictions?
Okay, so we're talking about a discrepancy
Yeah.
larger than a googol.
A Google. Is that even a real number?
It is a real number.
Okay.
It's a 1 followed by 100 zeros.
Okay, so a big number.
It's a very, very large number.
That's how far off we are.
That's how big the mismatch is
Wow.
between what quantum physics predicts
Yeah.
and what we actually observe.
Okay, so what does that mean?
Right.
Does our understanding of physics just completely break down on a cosmic scale?
It could.
Yeah.
I mean, some physicists believe that the answer lies in finding a way to unify quantum mechanics and general relativity.
Right.
These two pillars of modern physics
Right, the big ones.
that currently
God.
seem incompatible.
It's like trying to fit two puzzle pieces together.
Exactly.
Don't quite.
That aren't quite the right shape.
Yeah,
We
exactly.
haven't figured out how to make them fit yet.
So we need a new Einstein,
And
someone to come along who can look at these seemingly incompatible theories and be like,
yeah,
this is the missing link.
right. Or maybe, just
Yeah,
maybe,
sure.
we're looking at the puzzle wrong.
Okay.
Perhaps there's a completely different framework.
Okay.
A whole new set of rules that we haven't even begun to imagine.
Okay, that's both terrifying and exhilarating. I don't know about you, but I'm starting to think the universe is just messing with us.
Right.
It's like, oh, you think you've got me figured out?
It's like again.
Think again. Exactly.
right.
Every time we get close to, like,
Yeah.
some sort of grand unified theory,
Yeah.
the universe is like, hold my beer.
Hold my beer. Watch
That
them.
throws us another curveball.
Exactly.
Like that question about the quark and the black hole.
Right.
It seems so simple on the surface, right?
Yeah.
But then it just exposes these huge holes.
Yeah, it really does.
In our understanding of.
But,
Like,
but humbling, isn't it?
it's incredibly humbling.
Yeah.
And it makes you wonder, like,
Yeah.
what other obvious questions are we not even asking
Right.
that could, like, unlock even bigger mysteries?
Exactly. That's what makes this so exciting, though.
know.
It's not about having all the answers.
Right.
It's about embracing the unknown, being okay with, like,
Yeah.
not knowing everything.
Little bit of mystery.
Exactly.
And maybe that's the biggest takeaway from this whole deep dive.
Yeah, I think so.
We've barely scratched the surface of understanding these cosmic mysteries, but
Yeah.
in a way, that's kind of exciting, isn't it?
It is exciting. It keeps us going,
It
right?
keeps us going. It keeps us asking questions.
Exactly. That's the whole point of science.
Exactly. So keep looking up, everyone. Never be afraid to ask the big questions,
Keep that curiosity going,
even if the answers lead to even bigger mysteries, which
which they always do.
they always seem to, right?
That's part of the fun.
That is part of the fun. All right, folks, there you have it.
Another deep dive.
Another deep dive down, a whirlwind tour through some of the most mind-bending concepts in physics, guided by none other than Neil deGrasse Tyson and Brian Greene.
The dream team.
The dream team. We'll see you next time.